Alright, so we've made up our set of axes. Now I want to plot our points. So for my first pattern, that's 1 on the x-axis. How far am I going to go up until I stop? 5. So that's my first point there. Okay? Alright, who's brave enough to plot the next? There's no what? 17. We won't worry about that at the moment. We'll get to that when we get to that. Okay, who's brave enough to plot the next point?
I'm pretty brave.
Well, Flynn, plot our next point.
Oh, yay. Okay, cool. So what's that? 8 and 2, so that's...
Very nice, thank you, Flynn. Alright, next point. Caleb?
11.
Okay, just watching to see if Caleb's got it right.
Oh, God. This puts pressure on me much. Oh, there.
Yep. Very nice, thank you. Alright, and Cameron, you can do the next one.
I'll do the one after.
Or left-handed, this will be interesting.
So 4 and 14.
Yep.
Oh, damn. You can get it. Oh, you might.
Okay, do you want to have another go? Just turn it upside down for the rubber and rub it out like you would with... Yep, and have another go.
Whoa, that's weird.
You might have to go slightly further right to what you think you need to get it on there exactly. Much better.
Oh.
It disappeared.
Just go again.
Why did it disappear?
Because it's held it down.
What? It came back.
Try again. Okay, thanks guys, come on. You're going to have fun times doing this yourself soon enough, don't worry. You're down too low here, Daniel. Cameron.
Oh, what?
Cameron, you need to go up one. You're down.
Oh, right. Yeah, I got you. Yeah, I know what you mean.
Guys, just leave him be.
Jasmine's going to watch this.
Awesome, there we go.
Yes.
Okay, now we've run out of room on our graph, so we're not going to put in the last point there. All right, but there is something else that we could do here if we wanted to. What else could we do? What do you think, Caleb?
Join them up with a line.
Yeah, we could do. There's also a good reason why not to do that as well, though. Can somebody give me a good reason why we shouldn't join this up with a line? Daniel?
Because isn't a line graph meant for time?
No, line graphs can be used for any relationship. But there's a good reason why dots are good here and lines possibly we might not want to use. Well, let's just think about it for a second. I'm going to go ahead and rule in a line anyway. And there we go. So let's just think about what this line means. So this line is showing a sort of a pattern, right? So let's see. If we had the 1.5 term in our pattern, we would want to have 6.5 matchsticks. What are we going to do? Snap a matchstick in half?
Yes.
Yeah.
Really?
No. You could.
So, well, but will that actually continue our pattern properly? Can we even have half a term in a sequence of patterns?
No. Oh, yeah. What were we talking about?
Can we have half a term?
Yeah.
So just taking this back a step, why would we not have a line in this case?
Because it's pointing where you can have them.
Yeah, we're having exact whole numbers only. Alright, in between those whole numbers in this case doesn't actually make sense. Okay? Alright, so that's A and that's B. Our last question, C, is asking us to calculate a general rule. So what it's asking us to say is to write something where we go T equals and then something in terms of N. What could we write? Megan?
Does it add 3 to...
Yep, so we're going to be adding...
N plus 2. No.
So we're going to be adding 3 each time. So let's just think about that for a second. If I was wanting to add 3 to my first term, I'd just add 3. If I wanted to work out my second term, how many times would I have added 3 to get my second term? 2 2 times. For my third term, how many times would I have added 3? 3 times. So if I'm repeating additions of 3, what's a faster way in maths to show repeated additions of 3? Megan? Timesing, multiplying. So we're going to write 3 times n. That's going to show our plussing 3 each time. Okay, so let's see for our first one. If we put 1 in for n, 3 times 1, what's that? 3. So what are we going to do to bring it up to 5? Plus 2. Okay, so let's just see if this works for our second one. What's 3 times 2?
6.
What's 6 plus 2? 8. So it works for our second one. Let's just go to our last one, just to be triply sure. What's 5 times 3? 15. What's 15 times plus 2? 17. Alright. So it works for that last one as well. Okay, let's have a look at one more example. So I need to read through this one. And Daniel, can you just put that box here, please? Okay. The cost of hiring a tennis court is made up of 2 parts. A fixed charge of $7 plus $5 per hour. So if I was there for 1 hour, how much would it cost? Jamie? Nearly. George? $12. Okay, if I was there for 2 hours, how much would it cost? Emma? $17. Good, so we've got the idea. Okay, draw a table to show the cost of the court for up to 5 hours. Alright, so that's part A. For no particular reason, I'm going to put my table this way this time. Okay, so we've got 1, 2, 3, 4, 5 hours. Okay, and we've already done the first hour will be 12, 2 hours will be 17. What's the next one going to be, Dougal? Next one, George.
27.
Next one, Louisa. 32. Okay, so that's question A done. Question B. Draw a graph to show the cost of hiring the court for the first 5 hours. Okay, this time I'm going to have to really think about my axes carefully. So I'll draw in my y-axis, if I can. Not very straight. Hopefully you can do a better job on yours. My x-axis. Looks like we're missing a bit here. Okay, so my x-axis, I'm just going to go 1, 2, 3, 4, 5. I've only chosen 2 squares just to make it a little bit neater. Alright, my next axis, I don't want to have the same problem we had last time where I was running out of room. So I want to go all the way up to at least 32, but I haven't got that many squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12-ish squares. What could I do? What scale could I go up in? Yep.
You go for 3.
Okay, let's try that. So that we'll have 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36. That's plenty high enough. Okay, so now that we've got our graph and we've got a scale that will fit everything, let's have a go at drawing these points in. Okay, so the first point, 112. Who's going to have a go at drawing that in? Okay. Just when that circle thing comes up, that means take the pen off and try again.
I gotta keep doing.
Try again. Why can't you
Just
Why does it keep doing that?
Don't hold it down for so long.
there we go. Good. Okay, next point. Just before we draw the next point, what's going to be a challenge about drawing that next point?
That it's 2 points away rather than 1.
It's,
What else? Emma?
It's in between numbers.
Yep, it's in between the boxes. Okay, so it goes from 15 to 18, so it's going to be in between there, so you have to be aware of that challenge. All right, Marcus. Have a go.
That is mine.
You could have done that.
Ooh, hang on.
One more across. Yeah.
It's like a
All right. Nice. Thank you, Marcus.
Wait. What's wrong
Just let
with
go.
this?
Yep. Go again. Cool.
Yeah.
Excellent. All right. So Marcus has gone about 1/3 up the way, which makes sense because there's 3 numbers per box. Who wants to do the next one? All right, Dougal. Just let go. Try again. Nice. Okay, so he's gone a little bit above 21 there. Okay, Elliot. Okay, what's easy about the next one? Jamie? Yeah, it's going right on the corner, so that will make it a bit easier.
You don't know. It could be the circle thing.
Cool. Thank you, Elliot.
Well done,
Megan.
Okay, last grand finale. Alex. Great, thank you, Alex. So Alex has gone just below 33 there because he realises that 32 doesn't lie on the corner. Okay, now if I was at the tennis court for an hour and a half, what might I expect to pay? Yeah? Flynn?
You would expect to pay $12 because it'd be a base charge cost an hour.
Would it? When you park in a parking meter in town, if you put in money, does it... yeah, it increases your time, but I guess what I'm saying is, does your time reduce in a whole burst? Like, once you've spent $1, then your time all of a sudden goes down? Or does it count down? It counts down just in sort of linearly, doesn't it? Like, if you've got an hour on the clock, it'll slowly work down an hour. Like, if you leave after half an hour, there's still half an hour on there. So with a tennis court like this, if you were there for like part of an hour, would you expect to pay the whole amount? Possibly not. Maybe $2.50 or maybe a fraction of the hour. So given that, should we leave it just as points here or should we draw in a line? Okay, so let's draw a line in. Okay.
The time is choice 7.
There we go. Okay, now it's really important when you draw your line that you use a ruler because even that, what I've done there is not particularly tidy. It's the best that I can do in this machine, but I expect yours to be even tidier. Okay, make sure that you use a pencil for yours. Okay, so that's question B. Question C. Calculate the general rule of the hiring cost. Alright, so if let's just say the cost is C. Okay, what do I pay regardless of how long I'm there for? Yep. $7. So let's just put plus 7 there straight away because I know it's going to be 7 no matter what. Okay, then it's $5 per hour. So how am I going to show that I'm adding 5 each hour? Yep. Yep, 5H. So where H represents our hours. Okay, so if you're doing 3 hours, you go 5 times 3 plus 7. Cool. Alright, question D is asking us to use the general rule to calculate the cost of hiring the tennis court for 2.5 hours. So I'd write cost equals, then what? Ollie? Sort of. We're going to have 2.5 hours in there somewhere. What comes before hours in our function here? 5. So we're going to have 5 times 2.5 plus 7. Alright, then we put that into our calculator, or if you want you can do it in your head.
That equals 10.
What does your head tell you, Dougal? Don't be sorry, just tell me what your answer is.
19.5.
$19.50. Okay? Alright, so with all of these patterns, guys, you've got to identify how they're progressing. Think about whether points make sense or whether a line would make sense to join the points. Alright, then form that equation to solve whatever problem you've got. Okay? And that's what you need for here.